Boom, boom, boom. Boom, 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 ba-dum, ba-da-boom, ba-da-boom. If you've seen that movie, I am so sorry for you. I've seen it twice, okay? I don't want to hear complaints. All right, there's a really interesting study on the internet that I think you would like. Let me see if I can. This was an investigation into fast food claims. And so, of course, they put a really nasty looking picture of fries on the cover. These are actually yam fries, so they might actually taste pretty good. So here's what they looked at. They went to McDonald's, and the chicken fajita, it says it has 2.5 grams of fat, but they found up to 4.32. Yeah, okay, so that's a high amount, but is that luck? I mean, maybe one bad chicken fajita is going to have that. They also hit KFC, Taco Bell. They're looking at all these. They're looking at fat. They're looking at sodium. They're looking at calories. And they're finding, the headline says, fast food chains fail to meet the self-declared fat content. So what do the fast food chains have to say about this? Ooh, look at this. This is really interesting. Right here, to get some surveillance and background information, 3 is enough of a sample size. Their sample size is only 3. Well, do you feel okay about that? I mean, these are the kind of things you should be noticing. They tested the sodium. Oh, the Hawaiian pizza at Salvatore. I've never been there, but apparently it was good. They went to Arby's and Duxies and Harvey's and Subway and Wendy's. Fat content was terrible. In all cases, they were careful to order the items by the standard formula. They're going to get hammered from that in just a second. So, KFC, what did KFC have to say? Well, we work hard to ensure accuracy. On occasion, there are some variations. What she's saying is, sigma's not 0. We know it's not 0. So sometimes you're going to get a burger that has a little bit more. Sometimes you'll get a burger that has a little bit less. Wait, this is KFC. They don't do burgers. Point is, sometimes you'll get high values, sometimes low values. This shouldn't be an issue. McDonald's said, we take the consistency and accuracy of our declared values very seriously, which means nothing. Strong internal spokesman protocols, Pango Pizza. Where's the one that's really funny? Oh, here's one. Okay. Subway said, did you order cheese, mayo, other things? I mean, what you put on the sandwich matters. One thing I can tell you is we regularly test our products, and they're doing these kind of hypothesis tests, like I'm going to show you in just a second. This one I love. Druxy's vice president of marketing. He said, the issue is, when you test one, you find stuff. But is it really that? One store could have a situation that day, you just don't know. It's not like McDonald's. This guy's going to the grocery store if you need stuff. What he's trying to say statistically is, there's a lot of variability. From a sample size of 3, you can't necessarily tell a whole lot. Now, somewhere in here, and I seem to have passed it up, they talked about their margin of error. Where is margin of error? Let's do a search. Search margin of error. Oh, 20%. That's going to help me figure out what the sigma is for our hypothesis test. So we're going to go down here, where they have a little bit of the data, and we're going to test some stuff. So let's make fun of McDonald's. Why? Because they're big. That's really the only reason why. Their chicken fajita. The claim on the label says that it has 5 grams of fat. We buy 3 chicken fajitas. They took them to the lab. They got an average of 8.68 grams of fat. Ooh, that's higher. But how much is the error? Turns out the error is naturally 1.53. So getting 1 chicken fajita this high, well, gosh, that's what? Maybe 3 standard deviations? That should happen. Notice the small sample size. If we have such a small sample size, what have we got to assume to be able to do this? And the answer is assume normal. Is that what they did? Is that a safe thing to do? I don't know, but it happens all the time, and this is an example of it. So let's walk through a hypothesis test and see what it would show us. Null hypothesis is that the average is 5 grams. So, or according to McDonald's, they would say it could be 5 grams or even less than 5 grams. The only thing we really care about is the more than 5 grams part, right? So on our picture, where are we going to want our rejection region? We are going to care about that being higher. There's the area that we want to have reject. So we need to test if the fat is higher on average. Okay? So this is a one-sided test. I'm trying to do that because 2 videos ago it was two-sided. So we're going to test if it's less than or equal to 5. 5 is the number I'm interested in. Alternative is if mu is greater than 5. Okay? What alpha? Well, it didn't say, but 0.05 is the most common alpha. We'll just go with that. Is this a t-test or a z-test? The answer is, where did that number come from? Well, we have this 1.53. Is that the true sigma for all chicken fajitas that have ever been made at McDonald's or ever could be made at McDonald's? Of course not. Okay, so this is an S, 1.53 over the square root of 3, and that means we are talking about a t distribution. What's our degrees of freedom? If we're looking at 3 fajitas, our degrees of freedom is going to be 2. Okay? And this is a picture for X bar with 3 data points, if you want to put all the labels on your picture. And where was ours? Our X bar was 8.68. Where does that land? Does that land here? Does that land there? Let me find out. My t-score with only 2 degrees of freedom would be the 8.68 minus the mean of 5 over the standard deviation, which is 1.53 divided by the square root of n, which is 3. So this should feel very familiar. We've done it. Roll your eyes. I know you're bored. That's all right. Deal with it. 8.68 minus 5 divided by 1.53 over the square root of 3 fajitas. A t-score of 4.165. Okay, so where did this 8.68 land? 1, 2, 3, 4. Clear out here on the edge. There's where 8.68 lands. Now you can tell by the picture, that's a pretty high t-score, but remember the t is fatter than you expect. So you're probably not used to how far out 4.165 actually is. Let's go to the t-table and see if we can figure out how much is in that area. I need to scroll up here. I am talking about 2 degrees of freedom, because that's n minus 1 and my n was 3. So see how big these t-values are? That's all the way up to 31. If we were talking about a z-table, that's like a 3.2. So the curve on the t is a little different. We wanted 4.165. That's bigger than 2.9, but smaller than 4.3. So we're looking somewhere between these 2 values. So how much is in our tail area? Somewhere between 0.025 and 0.05. Let's go back to our picture. So here is our rejection region of 0.05, but here is our p-value, and I'm running out of room on my board. But how much area is there? Well, my p-value is between 0.025 and 0.05. So it's, let's see, bigger than 0.025 to 0.05. Now, I don't know exactly what my p-value is, but I do know that I'm comparing it to my alpha of 0.05. So I know my p-value is less than 0.05. A small p-value is reject. Reject, what are we going to decide? We are going to say the fajita at McDonald's is not. How much was it? 5 grams is what we were testing. 5 grams on average. So the newspaper article didn't cheat on the statistics. This test really does reject, but we did have to assume normality. And that's one thing those company spokesmen are trying to say. Sometimes there's one, sometimes there's the other. How do you really know what you got? Okay? They wanted to see the data. Turns out the people at the Vancouver Sun did not exactly tell them the data. And there's the debate. Let's try another example.